Thanks, Tim. Thanks for the introduction, and thanks for calling Cummins the most important engine manufacturer. That was very nice. Yeah, so one more time, you'll hear about Phase 2 and future NOx emissions, this time from an engine manufacturer's perspective. Make sure I can do that. So I'll start out with some history by looking at how diesel engine technologies have evolved over the past. They've been directly affected by the emissions regulations. So what you see here is the last 30 years or so of the emissions steps as NOx and particulate matter emissions have decreased over time, stepped down over time. There has also been an accompanying step change, you might say, in the emissions control technology. So sometimes, as in the case of adding exhaust gas recirculation in 2002, that came with a negative fuel economy penalty. But then in 2010, when we added selective catalytic reduction after treatment technology, we were able to get some of that fuel economy back. So that was really just in time for the Phase 1 CO2, the first ever heavy-duty CO2 regulations to be put into place and take effect later in 2014 at the first step of Phase 1. So it's an impressive history of delivering really significant NOx and particulate emissions reductions, over 90% probably from where we started on diesel engines. And now as we look ahead to the next decade, we face a second round of greenhouse gas engine standards, and now also regulators talking about potentially another 90% reduction in NOx emissions. So very challenging coming up. And the question is, what technologies will we need to be able to meet these new regulations? And what are the trade-offs that we'll face as we try to balance these two oftentimes competing requirements for fuel efficiency and NOx reductions? So the picture and the technologies that we need are more clear for what we need to do to meet the Phase 2 standards. So this set of stair steps looks at history on our 15-liter engine from Cummins, and starting at 2010 with the architecture that we had there of the cool DGR and diesel particulate filter, DOC, and SCR. This was back in 2010 when we thought near zero meant 0.2 grams NOx. Now it has a different meaning, but from there, with stable NOx standards, we were able to make incremental improvements in the areas of combustion optimization and reduced friction and parasitics on the engine, so that over the last several years, when we've been able to do year over year 2% fuel economy improvements on this engine. And so as we think about the technologies that we're going to need for the Phase 2 engine standards, we know what we need to do. We're confident we'll have the technologies to be able to meet or exceed the engine improvements that are required by the standards. And some of those technologies are the same areas that we've focused on the past 6 or 7 years. So combustion efficiency and optimization, improving air handling efficiency, making the engine breathe better, improving friction and reducing parasitics, and then also improving after-treatment efficiencies. And I show waste heat recovery there as a technology, not so much because it would be needed to meet the Phase 2 engine standards, but because it's something that we continue to look at and work on to consider if it's something that can be used to provide additional fuel savings for customers at some point in the future. So the engine has a role to play also in helping the vehicle meet its Phase 2 standards. So just as in Phase 1, where the vehicle certifies by using a simulation program called GEM, that is the path in Phase 2 for vehicles as well, but Phase 2 GEM is a lot more sophisticated, recognizes a lot more technologies and a lot more inputs from the vehicle OEMs. And one of the big changes is now that the actual engine that will be in the vehicle to be certified will be represented in the model, and that's through the engine fuel maps that engine manufacturers will have to provide to the OEMs. And so this is a big change. This is an area where Cummins, as an independent engine manufacturer to the vehicle OEMs, will have to work closely with them to understand what their needs will be from the engine. And it could be that the vehicle demands on the engine efficiency might go beyond what the engine standards themselves would drive. So that's something we'll definitely have to work closely with the vehicle OEMs to deliver what they need for the vehicle to meet its standards as well. There's also an option in phase 2, it was mentioned earlier, for mapping out a powertrain, an engine and a transmission, running those together on a dynamometer and mapping out the fuel consumption over a range of generic vehicles, and then using that in the simulation. So that's another area where we will collaborate with transmission manufacturers, Eaton and Allison, and vehicle OEMs that may want to take advantage of that option for their vehicle certification. So before I move on to NOx, I'll just spend a bit of time on the importance of public and private partnerships. SuperTruck's been mentioned before this morning. We learned a lot. We participated in the SuperTruck 1 program with DOE and other industry partners, and had a lot of valuable learning on fuel economy improvements and technologies that we've been able to incorporate and think we can put to use in phase 1, and as we go forward in phase 2, some of those improvements are already in current engines and vehicles, and we're fortunate to be participating in the SuperTruck 2 program that was recently announced, and look forward to the same kinds of learnings and being able to apply that in future technologies. So now turning to NOx. The technologies that we'll need to reduce NOx on engines in the future, and actually what should the regulatory requirements be, I think are less clear to us. So you'll see a lot of question marks on this page and questions on the following slide, because it's still early in the discussions with the regulatory agencies and in understanding what needs to be done to reduce NOx emissions. So there are several different engine and aftertreatment levers that are being discussed, and I'll touch on a few of those here. So one way of reducing NOx is to actually reduce the engine out NOx, perhaps with more EGR, but that comes with challenges and difficulties itself. One way to get around that is perhaps with low pressure EGR, so reducing the pumping work that you need to get the EGR into the engine, which can help offset some of the fuel economy penalty from EGR. If you look at the after-treatment options, I'll address a few of those. Fast catalyst warm-up, that is around getting the catalyst up to temperature during, for example, a cold start operation. So one example there is having the SCR, the catalyst on the diesel particulate filter, moving it up closer to the engine so it heats up faster than when it's downstream. So that's one lever that is being discussed, but that also could come with increased back pressure, which would be a fuel economy penalty. Keeping the catalyst warm is related to thermal management, where we would have to employ some kind of more aggressive thermal management, and we'll need to be smart about how we do that and try to make it efficient thermal management. Somebody earlier mentioned stop-start as a possibility there to keep the engine and the after-treatment warm during some of its operation. Cold after-treatment NOx conversion, there is some potential to address NOx with cold aftertreatment. One lever is a passive NOx absorber that could absorb NOx during a cold start on an FTP, but that doesn't provide the solution for sustained low temperature operations. So trade-offs like that, trade-offs with fuel economy, all of that needs to be considered as we think about what are the right technologies to help reduce NOx in the future. And really what the ultimate technology solution will need to be depends on first answering some other questions. So one of the big questions is, where are those excess NOx emissions coming from? Whether they're coming from cold start operation or idle or sustained low temperature exhaust, low load operation, makes a difference in what lever we use to try to target the NOx emissions. And then if that operation is not covered in our existing certification cycles, do we need changes to those cycles or potentially a new cycle to address that operation? And then also the level of NOx reductions that'll be needed to meet the ozone targets. You know, a 0.02 gram standard on an FTP, which is something that's being discussed, may not capture all the real-world NOx reductions that are needed if the operation, if the areas of high NOx operation are not contained within that FTP cycle. So a lot of questions, and you know, we saw earlier this morning that that CARB has an impressive list of research and studies that they're doing to try to address some of these questions, and there will be many more as we go along. And as we were in phase 2, Cummins is committed to working with the agencies and other stakeholders to make sure we get to the best path for going forward to achieve real-world reductions. So just a few other considerations before I close. So talked about some of the key questions that I think need to be answered as we figure out how to address future NOx improvements. And part of that is clearly understanding the problem and what we're trying to achieve. So that's going to take continued collaboration by the agencies and industry and others, and continued research. And a lot of that work has already started, but there's a lot left to be done. And as we work through the technical issues, we also need to keep as a target or keep as a goal having a single national program, not just for NOx, but also phase 2 greenhouse gases, so that engine manufacturers can sell the same product everywhere around the country. And another piece of that single program is having the appropriate amount of lead time to develop cost-effective, robust solutions, and then also having consistent effect dates to be able to implement them. So the same effect dates between California and EPA would be a goal for us. So that concludes what I had to say. I'll be happy to take some questions.